Okay, for section L, we're going to review similar triangles from geometry. There is a symbol for the word similar in geometry. It's this symbol that looks like the top of the congruent symbol. And triangles are similar if their corresponding angles are congruent, but the lengths of the corresponding sides are what we call in proportion, which we'll talk about in just a moment. So in the picture below, triangle ABC is similar to the other triangle, but let's identify the vertices in the correct order for the second triangle. So for instance, angle A is marked as congruent to angle E, so E should be the first vertex in the name of the second triangle. And angle B is a right angle. Angle F in the second triangle is also a right angle. And that leaves us angle D for the last. It's important that when you're writing a similarity statement that you understand that the corresponding angles go together in the correct order. Okay, there's a thing called a scale factor for the two triangles, which tells you how much bigger one triangle is than the other in terms of the length of its sides, or how much smaller one triangle is than the other, depending upon which way you define your scale factor. So let's take a look at some ratios here, ratios being fractions. So let's take a look at the ratio of side AB, which you'll notice from the similarity statement should correspond with side EF. So the ratio of AB to EF is 9 to 3, which is 3. Notice that the ratio of BC to FD, again, they're corresponding in the names of the triangle in the similarity statement. So BC to FD, that's 12 to 4, which is also 3. And then lastly, we have sides AC and ED, which should be the last pair of corresponding sides, and their ratio is 15 to 5, which is also 3. So the scale factor of triangle ABC, the big one, to the small one is 3 because of all of those ratios. But we can also define the scale factor as the small one to the big one. In that case, the scale factor would be 1/3 because 3 over 9 is 1/3, 4 over 12 is 1/3, and 5 over 15 is 1/3. All right, so let's put that to use. If we have a pair of similar triangles, in example 1 here, triangle ABC is similar to triangle DEF, we were told. So that means that sides AB and DE should be a pair that are in proportion. So those are going to be corresponding sides. Also, side BC to side EF, those will be a pair of corresponding sides. Now, in this picture, they're kind of lined up in the same orientation, but they don't necessarily need to be. So you need to pay attention to the order in which the vertices are named. And that leaves our last pair of corresponding sides as AC and DF. Okay, so if we're going to find X and Y, we're going to set up what's called a proportion, which is the scale factors between the two triangles, and no matter which set of sides we use, they should be equal. So proportion is two scale factors that are equal to each other. So I'm going to notice that we have that first pair of corresponding sides that we talked about. That is a known scale factor. Both sides are known. Okay, and then if we're looking at X, which is in that second triangle, then we can write that second scale factor 10 to X. Now I'm doing the big triangle over the small triangle, but you can do it the other way around. It's going to give you the same result. In order to solve a proportion, you have to cross multiply. So that means 15 times X is equal to 9 times 10, which is 90. Now if we divide 15 by 90, that's going to give us 6. So when we solve for X, we're going to get 6. When we solve a second proportion to find Y, we can use that same scale factor. So 15 to 9 as that first scale factor. But now we're going to use the second pair of sides there, which are y and 7. Okay, so now I'm going to cross multiply again in order to solve the proportion. So 9 times y is equal to 15 times 7, which is 105. And now I'm going to divide both sides by 9 in order to solve this. But what you'll notice is that 9 doesn't divide evenly into 105. So we're just going to simply reduce the fraction. You don't need to change it to a mixed number. You can factor 105 into 35 times 3 and 9 into 3 times 3. Cancel those common factors of 3, and we get 35/3. Just leave your answer in fraction form. That's okay. In the second example, we have a pair of overlapping triangles, and I recommend that if you have a pair of overlapping triangles, you should draw the two triangles separately. So I'm going to draw my first triangle here, XVZ. So triangle XVZ. And the sides of XVZ are 8. And this side right here is 7. 5 plus 2 is 7. And then the third side here is C plus 6. Okay, now we're going to draw that second triangle. The second triangle is XWY. And there's the sides of it are 6A and 5. All right, let's take a look at corresponding sides. Side XV should be corresponding to side XW. So XV corresponds to XW. Side VZ should correspond to WY. VZ and WY. And lastly, our third sides should also correspond. That's going to help us set up that proportion that we need to solve. So let's solve for A first. What you're going to notice here is that we have a known pair of sides, 7 and 5. So I'm going to use that first triangle, 7, and the second triangle, 5 on the bottom. And that should be equal to, and then I'm going to use my second pair of corresponding sides, 8 over A. In other words, the scale factors should be the same no matter which pair of sides you use. In order to solve this proportion, I'm going to cross multiply. So 7 times A is equal to 8 times 5, which is 40. And then divide both sides by 7, and we get 40/7. That's something that doesn't reduce. That's okay. Leave it as an improper fraction. And now let's solve for C. So in order to solve for C, we can use that same scale factor, 7 is to 5, as, or that equals the same ratio of, and our other side proportion is, or side ratio is C plus 6 divided by 6. Now again, we're going to cross multiply. So I'm going to cross multiply here, and we get 5 times C plus 6, make sure that you're using parentheses there, is equal to 7 times 6, which is 42. Okay, I'm going to distribute that multiplication over the addition in the parentheses. We get 5C plus 30 is equal to 42. And now I'm going to subtract off 30. 5C is equal to 12. And then divide by 5. And we get C is equal to 12/5. Again, improper fraction. It's totally good. Don't change it to a decimal. Much easier to just leave it as a fraction.